Bucknell got a Growing Greener grant from DEP to do a restoration of the Miller Run Creek. So the work that we're doing is to collect very high resolution elevation data that can be used by faculty like Dwayne Griffin, Carl Kirby, Rich Crago, Ben Hayes to create an actual restoration plan.
This data is then going to be used to build a whole bunch of wetlands that'll be out here to slow the flow and allow different pollutants and contaminants to fall out. So hopefully the water that ends up in Bucknell will end up being a lot cleaner and nicer and prettier.
The students are out doing two different tasks. Right now we're doing a task with a robotic total station.
This one is a laser that's on a rotating tripod, and it's going to be sending out a laser that's going to reflect off these prisms up here. And it then records the laser in a sensor, the reflection back, and by looking at the angle and measuring the time it takes between sending out a laser and getting it back, it gets a precise location within about 2 millimeters of elevation and spatial reference.
So that crew is going around collecting point measurements that are of interest. For example, pipes, where pipes emerge from the ground, is a point source that we're interested in. The other crew that is using the GPS system is actually doing more of the continuous topo, or just trying to map the topography of the surface of the Earth.
And we'll have a similar setup to this where there'll actually be a stationary GPS unit and a separate mobile GPS unit that will be going around, and we'll use the two together to get slightly less accurate data in terms of precision, but in terms of where it is on the globe, it can actually be more accurate.
That'll be used to determine where water will flow as precipitation would fall.
And that'll help us survey the land so we can decide how much we can look at it, we can project what kind of construction we want to do on the ground to help get more water in the Miller Run.
I'm Nick Urban. I used to be really into planes actually when I was younger, and my dad works at Newark Airport. And then I kind of fell out of the hobby, I guess. Around October last year, I found out about UAVs being an amateur hobby. So I thought, hey, I can do that. I kind of connected it to with a summer research project. Now I guess it's something I specialize in. For the Miller Run restoration project, the idea is using the camera mounted on the bottom of the aircraft. It'll take aerial photos, which I'll then compile into a map with the flight data from the aircraft, and that will be used for analysis and planning the new path of the stream and restoring it. The camera will be mounted on the bottom. That's just a Canon power shot, and that's separate from everything. It runs on its own in a continuous shooting mode. That will be taking pictures from a bird's eye view for mapping purposes. I have a video camera on the front of the plane, which is hooked up to the transmitter here at the tail, and that will transmit a live video feed from the plan of view of the plane. I plan before the flight a bunch of three-dimensional waypoints, which I have altitude data and then the actual X and Y coordinates of where the plane's supposed to fly. And the plane will try to hit each waypoint within a radius of error. I have it set to 30 meters right now, so as long as it comes within 30 meters of each waypoint, it'll count that waypoint as flown and we'll move on to the next one in the chain. So what I do is I plan out the flight on the computer first and load that to the autopilot. So I load all the waypoints onto this, and this will execute everything. Everything actually went exactly as it was supposed to, so I'm very happy with how things went.
Oh, looking good!